Welcome back to Module 6.1. In this lecture view, let's take a look at classifying an angle by its measurement. So in the previous video, I mentioned the different ways we can label our angle. So however you read, if you want to label this very first one here from ray A to O, then from O to B, then this is the angle that's formed, okay? We can use numerical value to label our angle as well. Sometimes I do that. Or we can simply call this angle formed by these two ray angles C, okay? Now, you probably remember some of these, okay? Angles that's classified by its measurement, all right? Any angle that is between 0 to 90, we call those the acute angle. So angle A here is an acute angle. All right, a right angle is referring to angle that is exactly 90 degree, and we always make our notation for 90 degree like that. All right, obtuse angle is any angle that is measured greater than 90 but less than 180 degree. So that my angle C right here. It's bigger than 90 but less than 180. All right, straight angle. Or sometimes sometimes you might see the word adjacent angle. Okay. Or sometimes I simply just saying the word straight line. Okay. A straight angle, adjacent angle, or when you see a straight line, okay, it's always going to be 180 degree. All right. Straight angle is always 180 degree. So classify the following angle. So when you see 180 degree, it got to be a straight angle. Okay, that's what we click on the homework. All right, 37 degree is less than 90, so that will be an acute angle. All right, this is a very interesting problem. Assume we can move the hour and the minute hand freely. Find the measure of the angle that is created when we move the hour to 2 and the minute hand to 4. So basically, this angle formed by the hands, by the hour and the minute, okay, by looking at it, we know this is an acute angle. All right. So we're going to use the idea of angles associated with the clock to actually figure out, okay, exactly how many degree this is. So let's just call this the unknown angle. So from module 4, we learned how to solve proportion. So that's what I'm going to do. So my x is going to be my angle. I'm going to put a degree symbol up here. All right. So this x degree is part of the whole entire circle because this hand, we can move this hand all the way around back to 4. So when I make a complete circle on the clock, that is actually 360 degree. But at the same time, though, when I move my minute hand all the way around, okay, the total, okay, the whole clock in 1 hour is actually referred to as 60 minutes. Okay, so the 360, all right, the 360 and the 60 minute means the same thing. 360 degree means the whole entire circle is 360. 60 minute means, okay, the 1 hour is actually 60 minutes. So up here so if we look at the minutes between the 2 to the 4, that's actually 10 minutes. Okay, that's actually 10 minutes. See, 2 to 3 is like 5 minutes, right? 3 to 4 is another 5 minutes. So this angle only consists of 10 minutes, okay, that's opened it up. So if I use a cross product to do this, 60 times x is 60x set equal to 360 times 10, which is 3600. So when I divide both sides by 60, okay, my answer is going to be 60 degree. So that means this 10 minutes opening, okay, is only 60 degree out of the entire 360 degree. All right. So kind of makes sense because if the hands is pointing at 12 and 6. That's actually 30 minutes, which is half of a circle, right? 30 minutes is half an hour. So this straight line forms what? It's actually occupying half a circle. So that's the reason why 30 minutes is actually equivalent to 180 degree. So think about this. What happened if the hands and the hands for hour and minutes is pointing at 12 and 3? Point 12 at 3. See, that's exactly 90-degree angle. So that means 15 minutes got to be equivalent of 90 degree. Okay? So that's you know why 30 minutes becomes 180 degree. So if it's like 75, okay, if I cover 75% of the circle over 45 minutes, okay, that got to be 180 plus another 90. Okay, so that's assuming I'm opening from all the way from 12 and go all the way right here. Okay, but most of the time we don't really talk about this way, opening this way, because then that means the angle I'm looking for, that means the angle I'm looking for is actually out this direction. Okay, because I know inside of it from 9 to 12, this is still 15 minutes, so that is still going to be 90 degree. Every 15 minutes is, every time when you see 15 minutes between the two arms or two hands, it's always going to be 90-degree angles. Okay, for 45 minutes, if you want to look at it from the 45-minute perspective, that's actually the angle on the outside. All right, so that's actually bigger than a straight angle. Okay, so that's just the way how we look at it. Just kind of watch between the two hands, just see how many minutes we have, and we can figure out what angle you open up to. Excuse me, I'm so sorry. All right, this thing called the angle bisector. Angle bisector is referring to a ray that divides an angle into two angles with an equal measurements. In the following figure, this M right in front of the angle means measurement. The measurement of angle A to O to B. So let's find A to O to B. So from A to O to B, that is actually 60 degree. If that's 60 degree, and from B to O to C, from B to O to C, this is another 60 degree. All right. Then they tell me that the ray O to X and O to Y are angle bisectors. Find the angle from A to O to Y. All right. So basically, I already know my red angle here, A to O to Y. I know inside my red angle, I already got 60 degree. And knowing O to Y is ray O to Y is an angle bisector, it bisecting my 60 degrees. So that means this little piece right here is only 30 degrees. That's the reason why my drawing look exactly like 90 degrees, because that's what it is. You take the 60 you already have plus the remaining 30 degrees. Okay, that will tell me angle A to O to Y is 90 degrees. There you go. Okay. Because the problem can also ask you how to find from X to O, okay, from X to O to C. All right. So if I need to do that, let me just kind of remove this. Just pretend if the angle want me to find from X to O to C, that will be from here all the way up there. All right, knowing that this was from AOB was 60 degree already. All right, from B to O to C was also a 60 degree. So now this time from X to O to B, that little piece got to be 30 degree because the OX is another what? It's actually another angle bisector. So that means what I label in red, once again, is also another 90 degree. Okay, just by looking at it from the other perspective. Okay, so just real quick, talking about how we can classify our angles by its measurement: acute, right, obtuse, and straight angle. Straight angle is very important. Every time when you see a straight line, it's always known to be 180 degrees. Okay, and we also take a look at the clock problem, which is very interesting, and we mentioning angle bisector. All right, that will conclude this lecture video. Thank you for watching.